Okay, I think I've finally got this working. Apologies, this has taken me a fair while to get going. Okay. Damn it. Okay, I guess we'll get started. I'm just going to switch this off because you don't need to see me. And switch this off. I'm just going to check this up here. Okay, so anyone who's out there at the moment, apologies for the minute of wasted your time. We're going to go through some robotics revision. Basically, I've already handed out the exam supervision or the exam revision sheets. So we're going to go through all these right now. So basically, the first thing we're doing is a spatial awareness thing. So on the left, I've got a picture of some kind of Lego. This is the way we connect the little Lego at the front to stop it from falling over. What you need to do is look at all these different pieces here and just simply write down exactly how many of them you need. Alright, so I've got here, looks like I've got 1, 2, 3, 4 black pieces, so just a 4 there. One of these, looks like I've got 2 of them. One of them, and one of them. But if I look carefully, I've got one here and another one under there. So it's, as we said, it's all about spatial awareness. Alright, pretty simple, just to get you started. Next task. Now each of these is a sensor or motor. Alright, so you will need to know what each of these different things are. You won't get all of these in the exam. You'll get some of them. This is obviously the brick, and apologies, I'm trying to type with it, right with a mouse. A brick. These are large motors. This is a small or medium motor. Oh, I need to get my tablet out, don't I? Okay, down here is an ultrasonic sensor. So there's the sensors all across the front. I've got a light one. Some touch. And this is a gyroscope or angle or yeah, let's go with angle sensor, but any of those are fine. Okay, so you need to know what each of these do. You will also need to know how they're used, what program you would use for them, how you could use them to influence what's going on the bot. Next one. So this might be unfamiliar to some of you who did this last term. You might be going, oh, I can't remember how to do this stuff. So what you will need to do is, you've got here, this represents move forward, this represents turn left on the spot, turn right on the spot. So here's our little robot in the bottom corner. So the first thing we're going to have to do is go forwards. So if we look down here, here's the code. So I'm saying go forward, what's in here. Then I'm going to turn right, which means turn right on the spot, which is going this way. Then we say go forward. And I'm just going to draw a quick little bot. Okay, so here's my robot. Okay, so he started off going up. Right, so he started this way. Right, we've now gone forward, which takes us to here. We've turned right. We've now gone forward, we've turned left, we've gone forward, we've turned right, forward, forward, left, and then forward, forward. So it means, and then we've stopped. So we've stopped in B4, right? So that would be our answer. So where does the robot end up? B4. Right, pretty simple. The next one, which you need to do is, okay, now you need to write your own code to get to here. So again, if I'm going to bear with me. Yeah, do this. Okay. Do it this way. Okay, so here's our arrows. And I'm just going to make a quick arrow. Oops. Move that up there. This. Sorry, I would have had this ready, except fortunately, if I go back and do it, I'm going to give away all my different codes I want to use. I'll flip this, transform. Flip that one, and last of all, alright, so starting again. Alright, cool. Alright, so here's our robot. He's there. I need to get to there. So I want him moving forward to start off with. Okay, so first of all, I'm going to go forward. To put him to here. I then wanted to get up our arrow thing we had before. Represent our bot. Bingo. Okay. So this is my bot. Alright, so it starts here. I've now gone forward to there. I now want to turn right. Turn right. So my robot is now facing this way. Now you can do any way you want. You can go up and around here, whatever. Next I want to go forward. Maybe twice. 1, 2. I now need to go up, turn left or turn right. Let's turn left. Remember, this isn't actually go left. This is actually just turn on the spot. Now I want to go forward. Okay, which goes into there. I now need to turn right. Forward, forward. 1, 2. Turning right again. So turn right, we'll do this way. And go forward. And there's the right, it's on the X. Okay. Now, next task isn't right. I've just written this code. Okay, so now I actually need to write the brick command for this. Alright, so this is a little bit more difficult. You started off with something that looked like this. had two circles inside it, which represented the two wheels. Okay, and you want to go forward. Right, so it's just like that. And remember that you have to say B plus C. Right. And that's that one there. Now, technically, you would actually need to tell me how far you're going with that. Okay, if you're going for the full marks, you would then go forward one, but that's fine. Normally, this would say on here, if you're doing the brick program, it would say forward. Sorry, it'd say go forward for 10 centimeters or something. 10 or 5, whatever works. Okay, I'm then going to turn right. It's a very similar one. Sometimes it's easier just to do it with pen and paper. Always. Okay, I want to turn right. Right, so this is this one I'm doing. Right, so put that one on there. So I'm turning right. Turning right 90 degrees. 90, I don't know how many degrees. And there we are. Okay, and so on. Alright, so you need to go through and do all this code to see how you can do it. Right, it should be fairly simple. If you want, you can use the navigator. Oh no, you've been asked to use brick program. So yeah. Next one. Now we're up to the computer navigation. So for those people who can't remember or didn't get much into this, very similar. So here you can see I've got two motors turning at 75% using B and C. They're going to keep turning until we get up to here. This is a proximity sensor, right? Ultrasonic sensor. When it gets less than 50 centimeters, then we'd stop and do the next thing. In this case, it's looks like double motors turn right, 40, like turn right 40 at 75 for one rotation. So we're going to go around the corner, and then we're going to go forward for 5 rotations. Okay, on BC and this one. So you need to understand what's going for this. You won't get this code, you'll get something different. But if you need hammer this, come and see me. Otherwise, it's good to have a bit of a look up on the internet. Okay, engineering challenge. Okay, so for the engineering challenge, you are going to get something which will require you to answer something. So here you need to design a robot, pick up a block and lift it up 10 centimeters. And you need to include the rough drawing of the robot and the code that make it happen. Now, we discussed this today. Basically, the idea was you would have some kind of forklift idea. Let's go like this, forklift. Okay, with something like that. And wheels. Okay, because I like it, I'm going to do a big wheel. Alright, so here's my wheels, and maybe a little wheel on the back. And we have our block, which is here. Now, what we're going to do is we're going to get this, oops, like that. We're going to get this. We want the whole thing to move forward. Right, so move forward to where this block is, and then we're going to get this part to then lift up 10 centimeters. Actually, maybe it's these parts to then lift up 10 centimeters. Now, to do that, I need to. So that's my design of the robot. Include a rough drawing robot and the code to make it happen. So to get this happen, I actually need to control this first motor. So it's going to be something like this. or something like this. So basically, I've got two motors here, one on each side. Don't forget. So I'm going to say something like two motors connected to B and C, and these are going to go forward, right, until our ultrasonic sensor, right, so which is plugged into 4. If that gets less than 5, really it should be less than 0. Okay, once it gets to there, then I want these motors to stop. Right, so it's moved over. I then want the single motor, the square motor, something like that. You'll remember it from, that's this motor there. Right, I want that motor, okay, which is plugged into A. I want that motor to, no, it's normally it's done a bit like this. No, it's going to go, yeah, so we want that motor to go up, and that will lift it up. But you might do that for a certain amount of time, or a certain amount of distance. I'm going to use a time. You could also use rotations, but use time to demonstrate that I know time might actually time doesn't really plug in anything. Time for 5 seconds. Take 5 seconds. Right, there's my you'll be given a different engineering challenge, but if you can attempt something like this, then you're doing well. Possible questions. So you will get a issue. Right, it could be any one of these. It might be a different one. I can't really see the point of me making something completely different that you haven't been exposed to. So, should drones be delivering pizzas? We've discussed this in our last group, but we also talked about driverless cars in the first one. Should drones be delivering pizzas? You need to give me two. So the story goes that Domino's Pizza actually have a drone that delivers pizzas. So it drives along, keeps it hot, and then when it gets there, it opens up and someone can grab it out. So you need to know the two pros and two cons for that. Now, if you want, you might remember we did an issues compass. Right, so if you want, you can do something like this with you, right? Pizza Hut or Domino's. Both of those are going to be affected. Society, of course. Society. And the other group might be, I don't know, criminals. Or you might be doing driverless cars, or it might be doing should coding be a thing at school. Again, these would say the same. Coding would be me, teachers maybe, and parents. Probably put them around the other way. Okay. The idea of what you're doing here is you're telling me the positive, negative of each of these things. So, Alright, so here you'd say what's so good about this, coding being taught every year at school. Well, from my point of view, as a student, I get to learn coding. Positive, so which will help me later in life. Negative could be, who knows? I've got to learn extra material. Teachers, positive, negative. Parents, positive, negative. Society, positive, negative. So that's a good way of actually getting down on paper very quickly pros and cons from different aspects, which makes it easier then to do the rest of it. You'll have to put in your own opinion as well. Okay, next bit is the ore exploration. So for the group in term 1, we had the different aspects of this. 0 I've taken to mean that there's nothing in this area, and then so 1 is first square, a 2 would be second square, third 1, 2, 3. There's something there, right? So here we've done research from either side, and this is what we've got. So if I go to the next one, I can do this. No, I cannot do that. Okay, so if I go to the next one, I'm going to have to do it with squares instead. Sorry. So this, by the way, on yours is not a 0. It's a 5. It should be a 5. Right. So I'll do this. I'll do this. Just going to move this back. There we go. Fixed. Alright, lock this. Alright, so back to this. So if I look across 0, there is nothing down there at all. Okay, so I can just go sweet, nothing. You don't have to put dots in. I'm just doing it to say that I've done it. There's nothing in this one either. Okay. Now for the good stuff, 1, I've got something here. Okay, and that checks out with that. 6, 1, 2, 3, 4, 5, 6, something here. Nothing. 3, 1, 2, 3, and 2. Okay, now that's fine, but we have to make sure we do it from both directions. I think I've made a mistake again. Not to worry. Alright, so here's 6, something there. 2, 3, 5, 1, 2, 3, 4, 5. There should be something there. So I've probably made a mistake up here as well. 2, 5. Alright. That's why I did that. I should have made a mistake in that one. Well, regardless, it doesn't matter. What I did want to point out though is that in here, we don't know what is here. Right, because here that's blocked, so I can't see anything behind here. However, I can look from this way. Can't see that. Here, 3 blocked, so can't see there, but that's okay. Can't see there, but that's okay. Don't know. No idea. Alright. 5, well, wherever that was meant to go. 2, I can't see in 2 different directions. And I can't see down here. Right, so there's quite a lot that I'm missing. Alright. The people in the first term suggested, well, you could just scan from this way. And that's a good point. If I went and scanned in here, I would go, let's say 1, 1, 2, 3, 4, 5. Okay. If that's 5, then this doesn't exist. Right, this might be 1. Right, oh, that was correct. Whatever we've done there, who knows. Okay, if this is 4 and maybe 2. So if this is 4, well, that one doesn't exist. And 2, that one doesn't exist. But 1, 2, 3, 4, aha. So that's actually telling me some information. So by scanning from the other directions, I now know a lot more information. All right. And that's pretty much the recap of what's going on. Sorry if I've lathered around a bit. It's not uncommon for me. But feel free to go over this anytime. If you've got any questions, come and see me. But really, you've all done extremely well to pick up quite a difficult concept and quite a lot of material in a very, very short amount of time. Plus, also, you're putting up with me. So, good luck, and I will sign off and upload this and let you watch it whenever you want. Thanks. That's it.